Yeah, cool. Great. So yeah, we're Flyte, or we're Cradle, your Flyte, and we're here to talk about sort of how we're using Flyte today. As a co-founder, I'm obligated to do my little 5-minute introduction of who we are and what we do. I'll try to blast through that. This is our leadership team. So we bring together sort of the best in biology and machine learning. So I'm previously at Google Brain and Accelerated Sciences. Steph, is our CEO, was leadership at Research and Machine Intelligence. We have 2 excellent bioengineers on our founding team from Zymergen and DSM, and design from Uber and Booking.com. So what's our mission? So we're on a mission to make programming biology easy, and we're starting with a really narrow use case, which is improving proteins and enzymes. So really specifically, we want to take some of the cutting edge ML and make sure that it gets in the hands of the scientists who need it. Some of you might know proteins are incredibly powerful, but hard to engineer and design. I like to say basically everything interesting that's done by biology is done by proteins. So that gives you a sense of sort of how much you can accomplish with them. And most experiments in this area fail to meet their design goals and spend a ton of money doing that. So, tens to hundreds of cycles, thousands of candidates, tons of money burned in that process, and success rates in the 1% to 10% range. And these are also incredibly long cycles. So what we really want to do is bring some ML, particularly for practitioners who maybe don't actually have the background to do protein or enzyme engineering themselves. They're more sort of bioengineers at the genomic level, and they're stymied in their current project by their inability to do protein engineering. So the idea is, take a protein, select a set of properties that you want to improve, and generate the next round to test in your lab. And so we really want to be with clients from the beginning to the end of their optimization process. So we want to be there across multiple rounds, and we want to improve with each experimental round. And this is one of the places where we think we actually have a lot to offer as sort of machine learning as a discipline, because there's a lot of spooky action within proteins, and understanding how the data that you've generated at great expense sort of informs that decision is pretty tricky to do, but the models seem to do a pretty good job. Yeah, this is basically a recapitulation of that. The idea is selecting regions and mutations to make it those regions, which would result in specific property improvements. So here you see, this is a mock-up of the first version. Actually, I think this might be live now. Basically, what you put in is spreadsheets with your data, and what you get out is a spreadsheet with the recommended sequences. So it's a very simple tool. It's really aimed at scientists who don't have necessarily the data science or ML expertise to use these tools as they're currently present. So this actually kind of gets into a little bit what makes sort of our usage of, well, we don't know everyone who's using Flyte, but makes our usage of Flyte a little bit unique is that we're actually in our production loop. There exists training and metrics and everything, because customers are bringing new data to us, and that needs to result in new models for them. And so we have kind of this concept of we're training in the loop. And so the way we've decided to architect that is actually to have, our production front end call out to blessed versions of Flyte workflows that mirror what we've been doing in research, sort of that are the latest and greatest, and then get the results from those back. So. Also, feel free to interrupt me. I'm going to go at a pretty good clip because I have a lot of slides, but feel free to interrupt me at any point in time if you have questions. So again, the idea is essentially we give you sequences. You're an expert in your assay in your building of sequences and getting them to express in organisms. And then you take that back and we act as an assistive technology for you in deciding what the next set of sequences that you should test are to get to your sort of end goal faster. So, this is a particular challenge in that we're doing training as part of our production, but we have also lots of other things. We have, we're in the bioinformatics world, so we have lots of weird legacy tools, lots of machine types because of that. We've got, a machine that needs to always stay up that has like 800 gigabytes of RAM, and, certain jobs need to run on that. And we also have a large and growing team that's actively developing workflows. So I think we're at like 20 something. I'm looking at someone else because I can never keep track of what and I think we have like 9 or 10 people who are actively sort of contributing to this. And you see, we have a pretty robust set of workflows across a number of tasks, and most of them appear to be running, although, and it was like, I think probably those are mostly tests, but So the later part of this presentation, I think I'm going to talk a lot about sort of where we struggled and what we'd like to see improved, but I thought I'd spend a little bit of time, giving some positive energy. So I want to cover the stuff that we really love and we've gotten a lot out of Flyte. And I'm sure a lot of this is you've heard before. And so for us, when we were doing the evaluation of workflow systems, these first 3, provenance, reproducibility, and caching, were absolutely like table stakes for us. It's basically like, why do you have a workflow engine if you don't provide those 3? And we really like how Flyte provides these things. So in terms of like providing the reproducibility, not just through the Docker images, but also through, actually storing the configuration of the workflows in a database, giving things immutable IDs, all of that. Providing the provenance by providing the inputs and outputs, really explicitly, and all the type information associated with that. And then the caching is just, like a huge time saver, and also reduces our compute bill a lot, since it'd be pretty difficult to write logic which resulted in stuff never being rerun on accident the way we're designing the system. So we lean on caching pretty hard. And the UI is great for getting an overview of that. There's a little asterisk there in that we've run into enough bugs in starting workflows from the UI that's sometimes a challenge. But that leads pretty nicely into it's great to have a Python client. And even if there weren't, occasionally challenges in starting things from the UI, we would probably still be mostly starting workflows from notebooks using Flyte Remote. It's just a really nice way to interact with the system. We love the local development and testing being easy. And I think one of the big things that's been we weren't necessarily looking for when we went and tested out some workflow systems, but has been really big for us, is that we feel like the way the Flyte SDK is designed does a pretty good job of enforcing good development practices in Python. Particularly for newer devs, or maybe devs coming from a research context where code structuring is not as critical. It really helps people think in a stateless way. Make sure they're taking advantage of the Python first class features like type hinting and separating out redundant code and stuff. So that's actually, I think, been a pretty big impact for us. Yeah, here at the top you see a quote from Artur, which is I think pretty representative of how most of our teams feels. It's really sped up our development quite a lot.
Eli, this is awesome. I'm John. I'm a product manager on the Union side. I just had a quick question on the first bullet around provenance. Like, the Flyte will save its intermediate data sets in your blob store. How do you kind of track the artifacts on your side? Like, do you kind of store a link to an S3 bucket, or like what's the system?
Right now, this is very subject to change, but we have weights and biases, which is like a training monitoring thing. I don't know if you guys are familiar. So we actually store models and data sets and artifacts and stuff on weights and biases with a reference artifact that points back to the GCS location that was created by Flyte. So we never re-upload it to weights and biases. But right now, in terms of like the metadata around provenance, or like the visibility, we're relying on weights and biases for that. Some of that is like, you need kind of different like you need different kinds of provenance for the like the model training versus like the, you know, I ran this workflow and it produced this result. We talk a little bit later about like one of the things we'd like to see more of is like tagging and filtering by tags. The other note I would have on the flight, it'd be great if there was an option to have like human readable semantic blob paths. I think that would provide a lot more clarity where like you wouldn't necessarily have to go search like what is this blob path. It would have a little bit more metadata encoded in the actual path. I don't know. Do other people have thoughts on the provenance stuff? I think for us, there's so much stuff that we do that's sort of outside the context of what a more specialized tool like weights and biases would keep track of, that it's really important to have this kind of like top level, like real source of truth provenance thing. And like, obviously it would be great if, you know, there were more of the ML specific tooling, or like, you know, those other kinds of provenance. But like half-assed provenance isn't really worth anything because you break the chain. And so the fact that we do a lot of stuff that doesn't fit naturally into weights and biases, I think we really consider Flyte the source of truth here.
Awesome, thanks.
Cool. Yeah, so this results in some more complicated workflows. Particularly like our team's extensive usage of this. You see this has like 2 sub workflows, and then those are both composed together in a larger workflow. And we have a bunch of workflows that look like this. It's great that this works. This does start to get into sort of like our first challenge with Flyte, which is essentially like, how do we encourage good code practices when we're composing stuff? So like, at least from my perspective, when I see like a DAG like that has this nice kind of hierarchical, like maybe I would want to repeat one of these units or something, or like map over one of those workflows. I'd like to be able to build in some code isolation that mirrors the way the execution is structured. And the way that it feels natural for me to do that is have these sub workflows be packages which are depended on by sort of the code that's composing them. And in particular here, as the sort of the highest level workflow grows, you don't want to have to necessarily rebuild and re-register every sub workflow every time you change something in one of the others. And so we've made the choice to operate within a multi-package Python monorepo, which is, you know, not something that is, I would say, typical in Python yet, but I think it's growing in popularity, and you can see that as some of the popular Python packaging tools like Poetry, which is what we use, add support for this modality. This next bit I'm going to talk about is kind of like the challenge we've had in overlaying like a monorepo multi-package approach on sort of the Flyte concepts. So the first thing we want is essentially that I don't want to have to I want to be able to have separate dependencies, and like ideally a completely separate Python, you know, environment between development of these sub workflows, right? So like if package A depends on package B, you know, it's not like I'm directly depending on the dependencies of that package, right? There is this sense of indirection, which gives you a little bit more flexibility in versions and stuff. And we kind of wanted to mirror that in the way that we compose workflows. And so what we've done is that we've actually wrapped the task decorator so that when you're importing between packages, you import via remote reference for a Flyte remote. So in this example, if you have package A and you have tasks and you have this foo task in package A, you have package B and you have a workflow that includes foo as a task, right? That foo is a remote reference. And say you had, a package which had finicky versions and you were running into diamond dependency problems in the declaration of foo, because it's a remote reference, you aren't going to have to interact with that package when you define bar. Does that make sense? So I can get into like, this is at a very high level how the implementation works, which is basically we check if you're registering, right? If not, it's a pass through to the original decorator. And if you're registering, we get essentially is my current object in the registration path, essentially. So if you think of a registration as scoped to a subtree in the file tree, which roughly corresponds to a package, then we can say, is this object in the being registered subtree? And if it's not, everything in the subtree gets registered with that object as a runtime reference. And this allows us to actually decouple the packages of sub workflows, which has been nice.
Hey, Eli, this is Ketan. Hi, nice to meet you.
Yeah.
So isn't this the same as reference tasks? It's just that you automated the creation of reference tasks. Is that, if I'm understanding correctly?
We're literally using reference tasks. Yeah.
The only difference here is that we're at a moment importing something, we're deciding whether to give you an actual task or a reference task. The same goes for workflows as well.
Yeah.
Oh, how are you deciding that? That's based on...
You decide based on whether you're currently registering that package, or is your object, is that function that you're importing in the package that you're currently registering, or is it somewhere outside? If it's outside, then you do the registration.
Yeah, so
the referencing.
This enforces a little bit of an object boundary, or it enforces a little bit of an implementation boundary, because you literally can't import a workflow from outside your package as a non-reference.
Yeah.
Make sense?
But when you import, I saw in your previous statement, in your previous slide, the import was still loading the module, right? Or maybe I'm not.
Yeah, it's loading the module, but because this happens in the decorator, the module, right? Like if you're registering, the module is literally just a dictionary of reference tasks. If you're importing the module outside of your package.
Also, the way for this to work, you need to have local imports for tasks, right? So otherwise you would get you'd get your dependencies would not be there for the reference modules.
Yeah. But only
if you have import statements, those are still loaded, right? So that still may cause a problem.
The import statements are loaded, but you load when you're loading a module is just an object dict, right? It ends up being an object dict because of how the decorator is defined, it ends up being an object dict of reference tasks.
If a package has a specific dependency that
so this allows you to avoid large dependencies that are imported inside of the task. So that's kind of the right? So like if I have an import that will only ever be run inside of the wrapped task logic, that logic is avoided by doing the reference task, right?
Yeah, but I thought that should always be the case.
We do a split between the imports that are needed, the dependencies that are needed to compile the workflows and tasks, and the dependencies that are needed to run the logic within the tasks.
Yeah.
And then the former are just imported within the functions that define the tasks, so they're not causing any issues with the referencing.
Yeah, this is very similar to, we've had internal discussions of image spec, and the same issues come up here of compile time dependencies versus runtime dependencies, which today you have to kind of reason about yourself as a Flyte user.
Yeah, so this is just an attempt to, I think, remove some of that reasoning from our dev team. That seems to work pretty well for us. At least we get a lot fewer questions about like, why is this dependency not here? I don't need it for this package, et cetera, et cetera. Cool. So separate Python environments, smaller Docker images, no change to local development. Propagating version changes bottom up is cumbersome. That's a little bit like, is that a feature or a bug? That's a little bit like this isolation. Like you have to do a separate registration for each package in your monorepo, right? Which is, you know, if one registration updates all the artifacts for all the packages in your monorepo, do you have a multi-package monorepo, or do you really just have one giant package that kind of looks like a bunch of smaller packages? You know, there's a little bit of a if there's no actual like deploy boundary, is there actually a version boundary, right? Introducing need for reproducible versions across the dependency tree, that is like quite annoying. We have a little bit of a hacky thing of like a versions JSON file that tells you which versions of the reference you should fetch for the given package. This is a place where more tagging would be great. If you could tag versions with like branch tags, for example, and you know checked out a get branch and that automatically meant all your reference artifacts were fetched according to that tag. Something like that would be awesome. So that we didn't really find anything that didn't involve checking in another file, which ended up being slightly hacky here. This is a little bit getting into like how much do you want to step into the territory of a package manager as Flyte is kind of a. I understand there may be some trepidation in moving into that space. Yeah, cool. Okay. Sort of the next thing that's missing, and I think I've had a discussion with a few of you about this, is manually composing executions. So what does this mean? So like, let's say I'm in this large workflow where I have sub workflows which are dependent on upstream sub workflows. Iterating on that is slightly annoying, right? Because I need to, if I want to rely on the cache in the iteration of like a downstream workflow, I need to like make a change to the downstream and then re-register all of the entire workflow like together in order to get it to run. So it's slightly easier if I can kind of like grab the outputs of the upstream intermediate workflows and then just rerun that sub layer. You know, this is kind of like I'm just grabbing the outputs. If I just want to test one function at a time, you know, I kind of want to mock out everything else. So that's one use case. The other use case we found is hacking our way around dynamic, which is another one of those components that we sometimes struggle with in having edge cases. So this is essentially, you know, like dynamic is really what it's doing is running code that generates a workflow as a task. So this is kind of us moving that process just into our notebook, where we're able to queue up a bunch of workflows by depending on the outputs of, you know, unfinished workflows. The final thing is like, if I want to prevent or like I want to discourage users from just like copy and pasting raw outputs when they're moving from one workflow to another. The reason I want to do that is that breaks your provenance chain, right? You no longer know where that raw output came from, right? So I just want to make it easier for users to say, use the output of this workflow as the input to this workflow, right? And that way you preserve provenance information because the workflow that output came from is actually part of the input to the next workflow. And so we did two things here, seemed to work pretty well. I think this is still in a branch. I need to merge it, but the tests all work and everything seems to be working well. First, we just made Flyte workflow execution Flyte serializable. It's basically a data class. It's pretty easy to do. So you can just pass Flyte workflow execution objects around your workflow. And the next thing we did is we just made some syntactic sugar for like an output ref, which just encapsulates the concept of a workflow and an output name, along with some type metadata that allows you to not need to specify like the type that you're decoding the output as. So you see the syntax for that in two tasks here. Yeah, you'll also notice we have a little convenience. I don't think we have time to get into it today, but we have a little convenience pod template library, which we use to sort of compositionally like compose partial pod templates, which we found to be the easiest way to use that functionality by far. So uses Flyte remote here just means we're injecting the secrets necessary to authenticate to the Flyte remote into the task. Yeah, and the test kind of shows you the usage from the client side. Any questions on that? Cool. Yeah,
This
so
is
I
pretty
think,
cool. Actually, some of it you could contribute upstream.
yes, I think we would love to. We are like always a little oversubscribed, but I think
Yeah, for sure.
several of these we would love to contribute. And we have a bunch of just like kind of trying to smooth the flight learning curve stuff that I think would actually probably be easier to contribute than this, like the pod template library and stuff like that. That isn't listed here, but at some point we should get around to surfacing to the broader community. So there's, I think, two things that would make this work even better. One, from a security perspective, we find it a little bit sketch to provide full flight remote position, like to tasks. So we need more granular permissions on flight remote. We think at the very least, it'd be nice to have separate read and write permissions. So you could fetch, workflow outputs, and you could fetch already defined artifacts and not have access to the create verbs. Finally, this is another tagging thing. Like fetching the correct execution is kind of annoying, like getting the ID. So this is another great, there are already tags for executions now. I saw there's no list verb associated with that. That might be a yet. So I don't know if that's coming, but that's what we really love, is if like we could say not only like this is an output ref of type int, but like I want to fetch the latest thing with the tag, whatever, and get that output and feed it into this workflow. Like that would make this really, really fly from the perspective of I think our internal users. Cool. Okay. Some more housekeeping things we need. Deleting data is kind of big for us. We deal with, pharma companies are notoriously paranoid about their data, and so we need to be able to promise them that we can delete all of it. Yeah. And yeah, so this is basically like we can delete stuff in the bucket, obviously. It just kind of makes it disappear in a way that's not super transparent to Flyte. But we can't really delete stuff that's stored in the table. So right now we have two workarounds. Like basically we can either keep all of a customer's data in a separate Flyte deployment and just nuke that deployment if the customer decides to do takeout, or we can make sure that all of the sensitive artifacts are stored in files. So we've done stuff like instead of a list of sequences, we use like a NumPy array, or like a list of strings, we use like a NumPy array of strings, because then it gets stored as a blob and we can delete the blob. Which is definitely not intended usage, but does get us around this problem. So this would be really nice. And I think the other sort of large thing is better mapping and streaming. This actually ties back into the discussion we were having before about some of the model startup time stuff. Like the most common use case by far for us for mapping is wanting to do like batch inference over a large number of examples with like expensive inferences. But it doesn't really make sense to do in like a regular map, because every single map item has to correspond to a pod. If the pod startup is downloading the model, you're downloading like a, whatever 10 gigabyte model or 20 gigabyte model for every map shard. That just doesn't make any sense. So obviously we have to do like batches. And that's fine. It's like a little bit of extra boilerplate everywhere we use map tasks, which is kind of annoying. But the bigger problem is that it breaks caching, because you're caching based on batches and not caching based on items. So something that functions a little bit more here, like traditional MapReduce, where you have maybe, or like something like Apache Beam, where you have like more static shards, and then you're caching on like a per item basis. The other way you could go, of course, is you could go like full streaming, which would solve this problem sort of implicitly. If like there were stream primitives that were inputs and outputs to tasks, then obviously we could just sort of batch stream that way. For places, yeah.
Can I ask you a couple of questions in this? One is, you could do manually, you could batch, right? Like, and in a map task, and you
Oh, we
prefer not to do
did
that.
manually batch.
No,
But-
like without using a queue primitive, just like use like a list of lists, really, or a list of data frames, or
Yeah,
whatever, and then
we do that. That's one of the workarounds for batch batching. The issue there is then you're caching on your
Yeah.
map task breaks.
batch. Yep.
Because if you shuffle,
So,
then you break it. Yeah.
so yeah, so that is one of the reasons why the caching is the hard part over here. That's why we've been not doing it. Though array nodes, the way we have done it, one of the goals is to, and that's the new replacement of map task underneath. One of the goals is to have sticky pods and do something around it. So happy to connect, and let's
Yeah.
would love to understand and see how we can collaborate.
Yeah.
Another part is streams. Actually, there is an internal ref I had written like maybe a year ago. I am supposed to put it out at some point. Stream literals is what we call it. So it's the problem is the default implementation of stream literals is going to be hard for most people to just like, yeah, I want to just get it working, right? But would love to share it with you.
Yeah,
and
yeah.
see, like, how to work with it. Yeah.
Yeah, no, I'd be really interested to see how that works. So the workaround that we've done here, which we use some places where it's like really critical, is we just defined a queue primitive that we can pass around workflows that just is backed by a Redis queue. And then we've tried to make this feel as first class in Flyte as we can. So like there's checkpointing, which goes to like act queue items and stuff. It uses Flyte uses the Flyte type system to deserialize and serialize items onto the queue, stuff like that. It feels a little bit heavyweight for most of the things we want it to do, and it'd be nice if it were didn't feel that way, but yeah, serviceable. Cool. Okay, the last, and this is like a much broader topic, but this is something we find ourselves wanting quite a lot, which is just more broadly like higher order functions. So if I have a workflow and really all I want to do is swap out some internal component in that workflow that requires me to re-register, however many nested levels of enclosing workflow are there, just to get that swap. And that's fine for one swap, but if you have to do that with multiple subcomponents that have multiple valid, tasks or workflows to be that inner logic, you get a combinatorial explosion problem pretty quickly in terms of the number of registered workflows. Obviously, like, viewing DAGs as like a purely functional logic, the way to deal with this is currying. And what that requires is, some concept of being able to pass functions in as inputs and outputs, which is a bit of work. We think there's like most of the stuff for this is in place, but the key missing feature that is really the linchpin for this is like support for var args, like support for, this is an arbitrary set of args, and I'm able to forward everything that is unbound that was an input to this workflow to an inner task of my choice, right? Because without var args, there's really nothing here but like an enum for like fetching a task, which is, we could do, is kind of obnoxious and generally doesn't solve our problem, because it's generally not, you want to swap out something with the exact same signature. It's like you have a family of things that all like meet a protocol, and then they also have some additional configuration. And if you don't have, that just moves your problem up one level, right? Then you somehow have to curry all those things into the exact same signature, so on and so forth. So that's getting a little bit more into the like, obviously longer term, more stuff, like larger things that we like. But I think this is something we do find ourselves starting to hit the beginning of this combinatorial explosion problem. And maybe to give you a concrete example of where that shows up, this actually also goes back to this building models into Docker image that we were saying, is like we frequently find ourselves with kind of like a model agnostic pipeline, except for this core sub workflow, right? And this core sub workflow is incompatible between two model types because, for example, they have incompatible Docker images. Like they just have dependency trees that we can't fit together. So we can't make a Docker image that fits all of our models together in one Python package. It's just like Python dependency hell prevents this from happening. And so what we'd love to do is we'd love to have, one task, one workflow that's like, this is the inference task for this model, right? It has associated with it the Docker image that works. It wraps the model in a common interface, and we can swap it in and out of a workflow. And that works great, except that if you make that architectural choice across many components of your system, you get this combinatorial explosion problem.
Yeah, we used to call it interface tasks. This was actually 4 years ago we had come up. And there is some, if you found some hints of there, passing functions as a first class. The task templates are inherently passable and serializable. That was one of the reasons why they are, and Dynamic is essentially doing that. So we talked about it, but we've never talked about making arbitrary interfaces because that breaks compile time guarantees. And so args become extremely complicated, and then what is the caching is where the nuances lie here.
Args does throw a wrench in there. I'd be interested in talking about how you would solve this problem using task templates, because I think I was probably just going to hack another custom type serializer where I serialize a workflow in here, which is probably not the right choice. But
yeah. No, but happy to share like how I think we can solve this problem. But careening might still be, the absolute requirement of interfaces might still throw a wrench into this, like your potential usage. But I would love to explore more. Like we should.
Yeah, I mean, there is an intermediate here, right? Which is like doesn't support the var args, but it's at least nicer to use than like an enum switch remote reference thing.
Yep. Oh, that's completely doable.
Yeah.
Not even, I would make it as an input. I think your computer's dying.
Yeah.
All right. Go ahead.
Yeah. Cool. So I think that's our last slide. We have, I think, more stuff we could share. We ran out of time on the preparation side, as always, like the startup life. Just oversubscribed, but looking forward to sharing sort of more with you guys in the future.
That was great.
Any more sort of default questions or larger questions, sort of not default questions?
I think this presentation was great. Like it gave us a lot of tips. Can you tell us some more about? I saw the one quote, but in overall, like how did you learn about Flyte? How did you end up using it? And what was the aha moment for you?
So I think 9 or 10 months ago or something, and I embarked on what was supposed to be a very short evaluation period for workflow platform. So like we knew we needed a workflow platform. We had just like spaghetti code all over the place, and just like way too much random switch statements, and a lifetime ago, I worked on TFX at Google, actually. Which was, of course, dead on arrival because it was one of those projects that was like developed internally and then surfaced and didn't meet anyone's external needs. So I was aware of Kubeflow because that was kind of in parallel developed in open source. So I think that's where we started our evaluation journey. And then we looked at, we felt like it was making a little bit too many choices. We didn't really feel like the SDK was very high quality. And we looked at like, could we just build something ourselves on top of Argo? Realized the way Argo was doing caching, aka not at all, didn't really meet our needs. And we were just like looking for other stuff out there. I don't remember who it was who suggested Flyte.
I remember we also talked to some people who were using workflow tooling and then just collecting
Yeah.
what other people were using.
But so this
Airflow was also there.
we also looked into Airflow. So that, like, I think by the time we found Flyte, we were literally like a month and a half into our
Yes.
evaluation. Like,
and already like this is the last thing we're trying.
writing our demo pipeline in different workflow engines over and over and over again, and like wanting to like gouge our eyes out with screwdrivers. And I think then I think we got to Flyte and everything just worked, which was really nice. And the SDK felt high quality.
The difficult thing with Flyte was deployment at that point.
Yes, yeah.
And then once we've managed to deploy it, everything else was
and
sailing, I guess.
Also felt like the SDK was really high quality, which was super important to us because like we know we're going to be in Python. You know, we're doing ML stuff. We're basically like hard locked to Python. Like having some language agnostic tool was not super important to us.
Also, community chats and like general support in the Slack.
Yeah. The Slack community was also huge. I think in the early days we asked some quick questions and got really fast, great replies. So that was definitely a big influencing factor too. Yeah, we actually have a slide deck somewhere that we presented to our team internally with like all our evaluation of all the workflow tools and the pluses and everything. we could send that out if we'd have to make sure we strip all the confidential stuff out. But yeah.
Can you believe every company that Flyte folks? I talk to a lot of companies. Almost everybody has that thing. Nobody ships it out, and they ask me to ship it out, and I'm like, I cannot ship it out. This is not going to be fair. I cannot compare, but this is really great.
You're also want to make sure you weren't too harsh on the bad tools. You're like, was my frustration coming out in this slide deck too much? Yeah. So I think that's kind of the journey of how we got there. And then I will say, I think there was a pretty substantial warm up time for the team of like getting used to. Some of that was a lot of the team just not having experience working in any like workflow tool before. So like for me, where I'd written some stuff in Kubeflow, and I think for both me and Anna, who at this point were like maybe overly familiar with the classic abstractions of these kinds of tools, it was pretty quick. But I think for a lot of the team, it was it took quite a while to get acclimated to the tool. I think pretty much everybody is quite on board now and really likes it as a tool. But there was, I would say, at least a 2 or 3 month startup time where we're like moving over code always felt painful, and you're like, why is Flyte forcing me to rewrite this? Et cetera, et cetera. So
we've seen the cold start problem, but I think usually what we see is the cold start is a hump. We have to do as a community something to make sure that the cold start goes away. But people, once they get over the hump, it's hard to go back to other things. But yeah, so that's why help us, improve that cold start problem.
Yeah,
the thing is, you'll forget about it. Like you'll not remember it, and so then,
yeah, like so many things.
Awesome. Yeah, that was awesome. That's my question. Great. Any other question?
One last one. So if you, so I think you probably are in the biotech community, and we have seen a lot of adoption of Flyte in the biotech community as well as other communities. But what would you tell so many biotech companies come and talk to us and ask like, what would you tell them? What's like the one line that you'll say like, hey, this is why you should use Flyte, not use Flyte, whatever.
Honestly, I wonder how much of it is like there is just a little bit of gravity around it's the name that's being passed around in the biotech community. I don't think that's how we got it actually, but some of that, I guess you're going to have to decouple, like if it's a biotech company and it's a little bit less familiar with this programming paradigm, you're going to have to decouple explaining why you should use a workflow tool and explaining why that workflow tool should be Flyte. And I think both of those are pretty easy cases to make, and then you put them together and it's a pretty hard case to make because you're like constantly having to go, but like this other tool has this thing. It's like, oh yeah, that wasn't one of the Flyte specific things. That was just like a why you should use a workflow tool in general thing. So like in terms of Flyte in general, I would say the easiest thing is like it doesn't change how it feels to write Python as much as most of the other libraries. And a lot of, I think, biotech people at this point are pretty comfortable, working in Python. And you don't need as much familiarity with the other tools, like the more DevOpsy side of the tools, as, for example, something like Argo. The other thing I would say is it's not as opinionated about the use case as something like Kubeflow, where it's like Kubeflow has a much more like ML-centric tools around it. I may have to switch to Anna's computer because my computer's about to die. But I guess that's does anybody else have thoughts on biotech in particular? Why for Flyte? I think those are the two main things. It's a little bit more friendly to people who aren't like really hardcore DevOpsy. Like I was able to deploy Kubernetes, to my toaster type people.
Yeah, I think something that's not ML specific is that in biotech, you're using also a lot of these classical tools and that have very different infrastructure requirements. So Flyte is doing a really good job here, providing this flexibility when we need it. So as you said at the beginning, like one task that requires 1 terabyte of RAM, one task that requires like as many CPUs as you can find, one task that needs to run on A100 and so on. So we have like in one pipeline, multiple tasks that have extremely different requirements from the infrastructure perspective. And in Flyte, it's pretty much transparent when we write this.
Yeah, on the ML side, we have like embarrassingly parallel GPU enabled, fancy algorithms. And on the biotech side, we have like requires 1 terabyte of RAM and is single threaded C. And being able to support both of those things is pretty nifty.
That's pretty good because I think it's combining, your domain specific stuff with ML. That's where the power lies. It's not just doing ML or just doing your domain specific stuff. And eventually data. That's where. Thank you. That's a lot of value.
Awesome. That was great. Yeah, well, we are at time, and again, thank you all. Thanks to the entire Cradle team for sharing, for taking the time. I know it's not easy, so thank you again. I feel that we need some follow-up conversations. I feel like that some of your workarounds will be great additions to the project, and also some of the feature requests deserve a better discussion, probably in the contributors meetup, where we meet with all the maintainers and the steering committee. Will be a good sync place to discuss this. But anything, again, thank you all for joining. Thank you to Cradle for sharing your story here, and we'll see you in the next one.
For sure. All right.
Thanks.
Thanks,
everyone.
Thank you so much, guys.
Thank you.